Hi, welcome to Bloom. Today we are discussing the second chapter in A-level syllabus, Introduction to Computer. Today our focus will be on computer organization. As you know, the lesson has four main parts: history of computing, computer organization, computer architecture, and memory hierarchy. In today's video, we'll focus on computer organization. First, let's see what are the computer components. Basic components of a computer system has four parts: hardware, software, firmware, and liveware. The first three are components of a computer. As we saw, a computer has mainly hardware and software parts. Computer organization provides an understanding how all the hardware units are arranged and interconnected with each other. Computer architecture is all about the functional behavior of a computer. For example, it defines how the instructions from an application should be executed. Since the computer components only understand electric signals, the computer architecture will facilitate how the instructions will be translated to logic. Computer organization mainly consists of three parts: central processing unit CPU, memory unit, and input-output devices. The CPU has mainly three parts, that is control unit, ALU, arithmetic logic unit, and registers. Now let's learn about central processing unit in detail. As you can see, the central processing unit or the CPU is mainly connected to input-output devices and the memory unit, that is the primary memory. Within the central processing unit, there are mainly three parts: control unit, arithmetic logic unit, and the registers. Now let's learn one by one what are the main components within the CPU. ALU or the arithmetic logic unit is an important component in CPU. It carries out arithmetic operations such as addition, subtraction, as well as logical operations like AND, OR, NOT for the given instructions. Registers are high-speed storage areas in CPU. All data must be stored in a register before it is processed. There are two types of registers: general purpose registers and special purpose registers. These are few of the special purpose registers in central processing unit. Program counter or PC. This contains the next instruction to be executed. Then MAR or memory address register. As its name implies, it holds the address of the memory location that needs to be accessed. Then MDR or memory data registers. Again, as its name implies, it contains the data that is being transferred to or from the memory. MAR contains the address and MDR contains the data. And CIR or IR, it is current instruction register. It contains the current instruction that is being processed. Then ACC or AC, that is the accumulator. It stores intermediate arithmetic and logic results. We discussed about the arithmetic logic unit and the registers in the CPU, and the third main component in the CPU is the control unit. It provides the timing and control signals for the ALU and the registers and the input-output devices and the memory how to respond to the program instructions. So it is involved in the fetch, decode, execution cycle. To provide timing instructions, there should be a clock, and the CPU contains a clock. It synchronizes all the computer components along with the CU by sending out a regular electric pulse. The frequency of the pulse is known as the clock speed. It is measured in hertz. Higher the speed, more instructions can be performed. In earlier generations of the computers, the processor commonly ran at 3 MHz, 5 MHz, but nowadays processors run at rate of 3 GHz, 5 GHz. We learned CPU has three main parts: control unit, arithmetic logic unit, and registers. So when we need to access data or instructions, we fetch them from the primary memory through the system buses. But in modern computers, there is a small RAM built within the processor. This stores data instructions temporarily so that the processor can get the data and instruction fast. The processor does not have to wait to be fetched from the RAM. As we learned, registers are the fastest memory location in a computer, and this level 1 cache is considered to be the second fastest memory location in a computer. We will learn about these in detail in our future videos. System bus is the high-speed internal connection which connects CPU with the memory unit and input-output devices. It carries data, address, and control signals. In this diagram, we can see the three buses. Both address bus and control bus are unidirectional bus. The control units provide signals from the control unit to the memory unit or input-output devices. So it is a unidirectional bus. Then there is address bus. Again, we get the addresses are transferred from the CPU to either memory unit or input-output devices. So it is again a unidirectional bus, but the data bus is bidirectional. It can get data from the CPU or either from the memory unit or input-output devices to the CPU. So it's a bidirectional bus. Now let's learn more about memory unit and input-output devices which are connected to CPU and which are components of the computer organization. The memory unit that is connected to CPU is the RAM, which is also called as primary or main memory. It is very fast and directly accessible by the CPU. It is split into partitions. Each partition has a unique address and the content is in binary form. So the data is loaded from the hard drive or any other permanent secondary memory into RAM so that the CPU can access it fast. Then there are major hardware components, input devices and output devices. For example, keyboard entry is an input device, and there are other direct entry devices such as touchpad, remote control, touch screen, barcode reader, smart card reader, scanner, likewise. Then the output devices are the CRT monitor or any LED monitor, printers, speakers such as that. There are different types of storage devices used in computer: fixed internal hard disk, portable external hard disk, magnetic tapes, optical disks, flash memory. Likewise, we'll learn about this in detail in next videos. Thank you for watching this video with Bloom. Please watch our next lesson, micro instructions.